G'day everyone. I've wanted to do this video for a while because I've had it drawn for probably a few weeks now, and I'm getting around to do it. So what I wanted to show here was I previously did this diagram a while ago, so it's in the same document as this, and I felt that some of these angles on this maybe could have been presented just a bit more differently, and so I decided to actually do it based on the globe actually being on the axial tilt, and to only dedicate it to the actual side which is facing the sun at a particular time. So this this particular image right here, this is everything that is facing the African side on the right hand side. And one thing you'll notice here, it says the latitude is 20 degrees east, and I also picked 160 degrees west. So when you come to actually look at this, this is like splitting the apple straight down the center. So when you come to it, what do we got here? So we're going to start with South Africa, Libya, and Sweden. So we've got Benghazi, Struisbaai, and Ume. So we got somewhere down around here. Struisbaai over here, so South Africa. And if you draw a straight line straight up, and you come up to Libya, where is it? It'll be somewhere around here. I can't quite. There, Benghazi right there, and back up to Sweden, to Ulmo, which is basically here. And so as you can see, they're all in this dead straight line. So it basically cuts straight down like an apple, straight down the center. And when you look on the opposite side, we've got this, I don't know how to say this one, Unalakleet and Honolulu and Cook Islands. So that's in Alaska, Hawaii, and Cook Islands. So if we flip it over, if we go all the way around the other side and we go to Alaska, I believe this Unalakleet place might be somewhere up around by here, I think. It's been a while since, here we go, right here. So it's been a while since I actually drew this. So this was all the positions I could find which was at that particular coordinates. And there's Hawaii right there, and if we keep going straight down, we've got Cook Islands down below. So as you can see, I've split the planet straight down the center, and this line, this 20 degree line lines up with the 160 degree line on the other side, because obviously, you know, it's 180 degrees separate. So what's actually happening is here is the African side that's tilted down. This obviously is for a northern hemisphere summer. So basically the top north side is pointing at the sun, and as you can see, the angles at June 21st, which is basically the summer solstice for the northern hemisphere, is basically pointing within, obviously because of the accuracy on that time and date thing, within 1 degree of level. So we got within 1 degree and within 1 degree. So as you can see, all of these sun angles at the meridian are all looking dead straight out in this direction. And so when we flip out over to the Pacific side, and these guys are at nighttime, so Africa is at nighttime, we have the Cook Islands, we've got Hawaii, and we've got Alaska, all pointing at the sun. They've now twisted over, and as you can see here, 0.21, 0.7, and 0.26, you can basically see that they are at this axial tilt. They are all roughly within 1 degree angle of the axial tilt. So that just proves that the axial tilt is very, very pretty much dead on accurate for what we need. And what it does prove is that when the planet rolls around from day to night, that these locations, which are directly opposite each other on the opposite side of the planet, look in this same direction. They look in within 1 degree of level of this particular angle, which is set with the axial tilt. And what I did was I used all these angles. So I got 32 degrees, 81, and 50, and I put that on the, what is it, orange, white, and red. So this is orange, white, and red. So here we go: South Africa, Libya, Sweden, right? So I got 50, 81, and 32. 32, 50, 81, and it should be 50. All right. So, and if we look at the Cook Islands, we look at Alaska and Hawaii, we got 45 degrees, 88, and 50. So, oh, there's no pitch on that one. I'll have to fix that one up. Let me just quickly do it right now. Okay, so 45, 88, and 50. 45, 88, 50. Right, so they all match. And what you notice about this is that pitching them on a flat surface, where this is the dead center North Pole, and this is the South Pole edges, where basically they believe that the ice wall is supposed to be. And if you were to say that this is all of the Pacific side and this is all of the African side, the sun, according to the triangulation on this, is telling me that the sun is somewhere in this region here. Now, as you can see here, this pink line goes straight up, and I've put a tiny sun, a 52 kilometer wide sun, on that particular line. But as you can see, this white line strikes below, and the orange line strikes above. So how the hell am I supposed to target the sun in its correct position? I really can't. So what I've done is I've just gone and slapped it somewhere halfway in between, and it's coming up as a height of 5,160 kilometers high. Now, what's funny about this, right? What's funny about this is that if I was to go over here and look at the African side, so we've got all these angles right here. So I've the yellow angle here, I've put the sun at the halfway point, similar to what I did on the other side. And as you can see, South Africa sees the sun lower than what the sun is showing on this particular line, and at the same time Sweden sees the sun being higher. So, you know, these lines should all triangulate at the same location if we were to realistically trust what's going on, but they don't. And one thing that is very curious about the whole thing, right, is the fact that over on this side, this sun is approximately 4,674 kilometers high, whereas the one on the other side was 5,106 kilometers high. And also, if I do a dimension from the North Pole, which is right here, the sun on the Pacific side is 7,455 kilometers away from the North Pole, but then it goes to 7,098 kilometers from the North Pole. So not only is the height different, and of course all those angles can't point to anything logical at all, but the width of the ring is also what looks to be around about 350 kilometers out of whack on in difference. So when it spins around, it's not spinning around this perfect ring which is balanced from left to right. It is kind of wobbling in comparison to the North Pole. It's not this perfect ring. If we were to anticipate that this is consistent, then not only would all these lines be lining up and actually triangulating the sun a bit better than what it is right now, which is not, but this distance would also be somewhat similar. So it would be like 7,100 kilometers away from the North Pole on both sides. And you would expect the height to both be like 5,000 kilometers, equal, but it's not. So the sun is just doing whatever it wants. So like looking at this line between the two markers here, maybe for flat earthers, maybe if we were to give them benefit of that, maybe the sun is spinning on a funny axis. And look at that. Maybe if we were to humor this idea, then that would mean that the sun is spinning on an axis of almost 2 degrees. Is that possible? Does that make it any easier for someone to calculate where the sun is? I don't really know. But one thing I do like to do sometimes too is I like to go and get the heights of it, places that are even at higher extremes, because when you do that sort of stuff, it really mucks things up. Just like, for instance, when I did this one, when the top of Norway came through and it went absolutely haywire, and down in South America it went absolutely haywire. So yeah, so like in terms of this, the globe with its axis there, these lines are within 1 degree of this level line here, on both sides, on the Pacific side and on the African side. Yet over here, it's struggling to identify where the sun is, and it's struggling to figure out how far away the sun is from the North Pole and its height off the ground. It's varying in height. So if I was to, I'll try to give it the lowest height, just for instance. This one's 4,278, and its highest is 5,070. So that high mark was probably parallel. No, not quite. Not quite. It's more in that midpoint. See, now we go up to 5,400 kilometers high. It's just a mess. I'd love to add some more cities, and I probably will, because there's nothing better when it comes to proof than more data. You put more data on something like this, it'll show which one is actually wearing, bathers when the tide goes out. Because right now, the tide is out on the flat Earth, and it's struggling. So I'll leave you to think about that. Comment below, like and subscribe if if electricity flows through the power lines. See you later.